one of our atmospheric temperature controls that I want to talk about is how far away we are from sea level, or how far up into the atmosphere we go. Now, there's two different ways that we look at that. One is based on our altitude, and one is based on our elevation. They both mean basically the same thing. So if we were in our airplane, we're going to be down here on the ground. We're going to be going up through the atmosphere, and that height that we are kind of in the air would be referred to as our altitude. But we could also, if this were the lower elevations, as we go higher and higher and higher up through this, my goodness, we're going to go higher and higher up the mountain. So we're getting further away from sea level. But basically, if it's on the ground, then we would call that the elevation. All right. Now, two different ways of measuring how high up we are. One is going to be how far we are up in the sky. The other one is going to be based on elevation. Does it get colder as we go higher? It does. Okay, so either way, as we increase, as we go higher, it gets colder. But the reasoning behind it is different for each one. So let's talk a little bit about these guys. In a previous discussion, we were talking about our different atmospheric layers. And within those atmospheric layers, the bottom one is down here, and it's the troposphere. And what we know about in the troposphere is that we get light energy coming down, shortwave light, and as what radiates back off of the surface, depending on the surface albedo or the reflectivity, we could get light energy that bounces right back off, or what we will see is long wave heat energy radiating off of the surface. All right. Now, in the troposphere, the source of heat energy is going to be at the surface. So, within the troposphere, the source of heat, not the source of energy, energy is coming from above, the source of heat is the surface. Now, based on this, we went through and we created this great little graph that said that as we increase in altitude, that the temperature decreases until we reach that ozone layer, and then that's our stratosphere, and it goes up and then colder and then really, really hot. You might remember that. So down here in the troposphere, if we get in our little airplane, we're going to go higher and higher and higher in altitude. As we go higher in altitude, it's going to be getting colder because we're getting away from the source. So with altitude, it's colder because we're getting further from the heat source. Now, elevation, yes, we go higher and it will get colder. Different process going on there. Here's the deal. When we are looking at our valley versus going up into the mountains, right? We might go, Sacramento versus Tahoe. It's obviously going to be cooler up in Tahoe. Here's the deal. If, again, we could see the air would be very thick and dense, right? So we would have dense air down here. Gravity has pulled a lot of that air down. Up here in the mountains, the air is going to be the same combination of nitrogen, oxygen, carbon dioxide, and everything, but it's going to be less dense. And we call that rarefied. So the atmosphere is rarefied or thinner up there at our higher elevations. Okay, what does that matter? Well, here's the deal. You see, light wave energy is going to be coming down, and it's going to be heating up, or it's going to be hitting the surface. Some of that heat is going to be re-radiated back out as, let me find a good color, re-radiating out as heat energy, but because that atmosphere is a little bit thicker, it's actually going to be doing, or more dense, it's going to be better at insulating. So we're going to say more dense air, better at capturing that heat energy. Now up at the higher elevations, it's rarefied. So again, same deal. The light energy is going to come down and hit the parking lot in Lake Tahoe all the same. But as it hits up there and then re-radiates as heat energy, not as much heat energy is captured or stored. Less dense air is less dense, it's rarefied. Less energy is captured and stored. So what we start to see is it gets colder. So as the sun goes away and the heat goes down, nighttime temperatures are going to be a lot colder, lower nighttime temperatures. And so in order to warm things up during the day, to get it up to the same height, it would take a lot more energy. And so usually overall, because those nighttime temperatures, because it's not storing that air, the air gets very, very cold. So we have in the air with altitude, we're just further from the heat source. When we're on the ground, oh, it's chilly. The reason that it is chilly is because the air is thinner or rarefied, ED, rarefied air captures and stores less heat. All right, so altitude and elevation both have a play in this. However, they're for different mechanisms.